Okay, so one of this week is factoring, either with a greatest common factor and trinomials, or the difference of perfect squares. So I'm going to take you through a couple of these and give you a couple examples, and then you can go ahead and practice. So factoring, we always want to look for, is there a greatest common factor first? So in this one, we've got negative 16a to the 7th, 8a to the 3rd, and 4a. Well, the largest number that goes into negative 16, 8, and 4 is going to be 4. Now, if the first term is negative, your greatest common factor is going to be negative. So I'm going to take out a negative 4. For the first term, there are 7 a's. Second term, there are 3 a's. And in the last term, there's just 1 a. The most amount of a's that they all share is 1. So my greatest common factor is going to be negative 4a. And now I'm going to divide everything by my greatest common factor to see what is remaining. Okay, I want to make a note that if there are 3 terms in the original problem, there are going to be 3 terms when you write your leftovers. So we got negative 16a to the 7th divided by negative 4a. That's going to be 4a to the 6th. 8a to the 3rd divided by negative 4a is going to be negative 2a to the 2nd. And 4a to the 1st divided by 4a is, negative 4a is going to be negative 1. So you're done here, and your answer is negative 4a times 4a to the 6th minus 2a squared minus 1. So that's factoring with a GCF, and now let's take a look at factoring with a trinomial. Again, is there a greatest common factor? We've got the numbers 2, 3, and 5. No other number besides 1 goes into those 3, and since not all 3 terms have an x, there is no greatest common factor, so we're just going to go ahead and factor using our 2 parentheses. So we've got our first 2 blanks that need to multiply to be 2x squared, and our only options here are 2x and x. Our back numbers have got to multiply to be negative 5. We have a couple options. We have negative 1 and 5, or negative 5 and 1. I'm just going to go ahead and guess and check here. I'm going to put down the negative 5 here and the positive 1 over here. Now, what happens is we've got to check our middle. So 1 times x is going to be 1x. 2x times negative 5 is negative 10x. And if I add those together, that's going to be negative 9x. Well, the middle term in this trinomial is negative 3, so I need the middles to add up to be negative 3. Since that didn't happen, I got to find some other factors, or maybe change the signs of these numbers. So what happens if I put the 5 here and the 1 there? 5 times x is 5x, 2x times negative 1 is negative 2x, and if I add those together, I'm going to get a positive 3x, but I want a negative 3x. So when that happens, when you get the number correct but not the sign, just change the signs. So this is going to be negative, that's going to be positive, and now I'm going to get that negative 3x. So your answer is 2x minus 5 times x plus 1. Now in number 4, again, we're looking for a greatest common factor, and I think the greatest common factor here is 3. And no x because the 12 doesn't have an x in it. So I'm going to factor out a 3 and divide everything by 3. So I'm going to be left with 5x squared plus 19x minus 4. So now I'm going to see if I can factor what's left over. So bringing down the 3, setting up 2 parentheses. First blank has got to multiply to be 5x squared, so the only options are 5x and x. For 4, I've got 2 options. I've got 1 and 4, 2 and 2. Now, it's going to be negative, so one's going to be positive, one's going to be negative. If I think ahead, I've got to be adding to get to 19, so I know whatever I'm going to multiply needs to get pretty large. Well, what I multiply by the 5 is got to be pretty large to be 19. Looking at my options over here to get 4, 4 is large, and I know 5 times 4 gets me 20. So what happens if I put a positive 4, and then I make the 1 negative? Let's check those middles. Negative 1x and a positive 20x. That's going to give us positive 19x, which is what we want. So our final answer with the greatest common factor is 5x minus 1 times x plus 4. Going over to 5, again, you want to make sure that you have a greatest common factor. In this case, we don't. And in this case, we've got just two terms. But notice what kind of numbers those two terms are. They're called perfect squares because you can write them as factors of each other. 2x times 2x is 4x squared. 9 times 9 is 81. Now, in order to get the middle term to be 0, one has to be positive and one has to be negative. So if we check these middle terms, we're going to get a positive 18 plus a negative 18, which is 0, which makes us have no middle term like our problem does. It doesn't have just an x term. So these are called the difference of perfect squares, where you just basically take the square root of each number, and one is positive and one is negative. Now, why do we use factoring? Well, we use factoring in order to solve. So if we're looking at solving by factoring, we want to get it equal to 0 first, and then we're going to set each factor equal to 0. So 2x plus 1 equals 0, and x plus 8 equals 0. So, and then we just solve these as two separate problems, and you're going to get, for the most part, two different answers. So x is going to equal negative 1/2 and x equals negative 8. Okay. Now when there's a greatest common factor, okay, you still set each one equal to 0, so x equals 0, and then x is going to equal negative 3. Okay, now we might have to factor these, so again, look at, does it have a greatest common factor? This one does, so I'm going to take out an x. It's going to be x equals 0 and x equals a positive 5. Going on to number 10, is there a greatest common factor? Yes, there's a factor of 5, so I'm going to have x squared plus 2x minus 48 equals 0. So now I'm going to factor what's left over. Let's see, factors of 48 are 6 and 8, and the 8's going to be positive because I need it to be a positive 2 in the middle. And then you're going to set each factor equal to 0. You know, you can even do the greatest common factor, but obviously 5 does not equal 0, so that doesn't really matter. And we have x plus 8 equals 0, and x minus 6 equals 0. So x equals negative 8, and x equals 6. For number 11, again, this is the difference of perfect squares since 6 is a perfect square and 9 is a perfect square. Be 4x minus 3 and 4x plus 3 equals 0, and you're setting each one equal to 0. So let's see, x will equal 3/4 and x will equal negative 3/4. For number 12, the only problem with this one is it's not equal to 0, so I'm going to add 14 to both sides. 2x squared plus 11x plus 14 equals 0. Now I can go ahead and factor, and since there's no greatest common factor, I'm going to set up my two groups. And let's see, if I do 7 and 2, let's put the 7 here and the 2 there. If I check, that's going to be 7x and 4x. That gets me 11x. So I know that I'm good. And I'm going to set each factor equal to 0. So x is going to equal negative 7 over 2, and x equals negative 2. So that's how we use factoring and solving by factoring. So a little refresh from probably last year or the year before. So go ahead and try the practice, and let me know if you have questions.